Welcome back. I would like to look at one final example of a rational inequality that we are going to solve algebraically. So our first move, we want to get 0 on one side. So if I move part of this over, if I subtract the right-hand side, x plus 2, x minus 4, from both sides, then I will have 0 on the right, greater than or equal to, and my original left-hand side, x minus 1 over x plus 5, minus x plus 2 over x minus 4. So it's a little bit clunky to move these things around, but you can add or subtract anything you want from both sides of an equation, including big, weird fractions. Alright, now I can't go any further until this is a single rational function on the left. Right now I have two separate rational functions, and they have different denominators. So if I space things out a little, this is x minus 1 over x plus 5, minus x plus 2 over x minus 4, and this should all be less than or equal to 0. So I would like to perform this subtraction, and at the moment I don't have a common denominator. So my LCD, before I can subtract these two fractions and combine them into one, I need a factor of x plus 5, the denominator of my left-hand fraction, and a factor of x minus 4, the factor in the denominator of my second fraction. So that's what I'm shooting for. I am missing an x minus 4 from this first fraction, so if I want one in the denominator, I have to supply one in the numerator. And I am missing the x plus 5 from my right-hand fraction in the denominator, so I have to supply one in the numerator as well. Alright. So if I FOIL out this first numerator, this is x squared minus 4x minus x minus 5x plus 4, and I am subtracting the product of these two factors in the second fraction. So if I FOIL those, I'll get x squared, 5x and 2x gives me 7x, and 2 times 5 gives me 10. Now all of this is divided by my now common denominator, and I think I'll keep it factored for now. X plus 5, x minus 4. Now the reason that I FOILed my numerators is because I would like to try to simplify this. This is a pretty rough looking equation or inequality. This function would be really difficult to analyze, so let me simplify it if I can. This is actually x squared minus 5x plus 4 minus x squared minus 7x minus 10 all over x plus 5 x minus 4. And we can combine some terms. I have an x squared and a minus x squared. Negative 5x, negative 7x gives me negative 12x, and 4 minus 10 gives me negative 6, all over x plus 5, x minus 4. Alright, so now I have my inequality in a satisfactory form. I can find the zeros of the numerator. So my numerator, negative 12x minus 6, when is that equal to 0? Well, if I move the 6 over to the other side, negative 12x equals 6, when x equals negative 1/2. And our denominator, see now why I left it in factored form. If I say x plus 5, x minus 4 equals 0, we can tell right away that this happens when x equals negative 5 and 4. Now, right from the get-go, looking at these two denominators in our original problem, I know that solutions are definitely not going to be 5, or negative 5, or positive 4. Those can't even be plugged in, so they definitely can't be part of the solution. So these, if these are the endpoints of an interval that we choose, we are not going to include them no matter what. They are just there to help us tell where the graph might change its sign. So if I plot all of these, negative 5 is the first, then negative 1/2, and finally positive 4. So I have, it's a little bit difficult to see, but I actually have 4 intervals of interest. The space between all of these and the space before negative 5 and after positive 4. So I'm going to base my decisions off of this function. Assuming that we did everything right, that should be okay. So if I pick an x value less than negative 5, say negative 6, what does that do for my function? Well, my numerator is negative 12 times negative 6 minus 6 all over, and I'll use the factored form, negative 6 plus 5 times negative 6 minus 4. So my numerator, negative 12 and negative 6, would be a very large positive number, and if I subtract 6 from it, I would get, I believe, 66. So that's a positive over, and my denominator, I have a negative factor and another negative factor, so those result in a positive, and the ratio, the quotient of two positive numbers is positive. Now that I have to decide, is that what I like or what I don't like? Well, this inequality is saying less than or equal to 0, so I do not like. That is not part of the solution. Now this trick with the signs, kind of ignoring what the actual output is, you don't have to go with that approach. You can actually calculate and find the number and then figure out what its sign is once you have it. So this is a matter of taste. I find this shortcut works well for me, but you can actually plug in negative 6 to your original function, or to the function that we're working with, and see what that number would be. Alright, so I want to plug in something in this middle interval between negative 5 and negative 1/2. I'm thinking negative 1 is a nice round small number. So if I plug negative 1 in, my function is negative 12 times negative 1 in the numerator minus 6 all over negative 1 plus 5, negative 1 minus 4. So my numerator would be 12 minus 6, that's 6, over 5, or negative 1 plus 5 gives me 4, times negative 5, negative 20. So our result there is negative. Don't care particularly what that number is, just about the sign. And we like negatives. Negatives are what we're going for with this problem. So I like that interval. And I'll come back later and decide if I like negative 5 and negative 1/2 as solutions. So let me try something in this next interval. So stuff between negative 1/2 and 4, I like 0. So if I plug in 0, that's negative 12 times 0 minus 6 over 0 plus 5, 0 minus 4. So I have 5 times negative 4 in the denominator, that's negative 20. And in the numerator, I have negative 6. So let's see, 3/10 positive. And finally, I'll pick a test number beyond 4. How about 5? So if I plug my x value into the function, negative 12 times 5 minus 6 over 5 plus 5 times 5 minus 4. So my numerator, negative 12 times 5, negative 60, minus 6, negative 66, over my denominator, 10 times 1. So I get a negative again, and we like negatives. Alright, so we like these intervals, the stuff between negative 5.5, negative 1/2, and the stuff above or greater than 4. Those x values will work. So the only thing left to decide is, do we like the endpoints? Well, we already said that negative 5 and 4 were definitely out. We're not allowed to use them. They aren't part of the solution because I can't even plug them in. But what about negative 1/2? Well, let's check. If I plug negative 1/2 into my inequality, does it work? Well, negative 12 times negative 1/2 minus 6 over negative 1/2 plus 5 times negative 1/2 minus 4 equals, now in the numerator I have 6 minus 6, which is 0. And remember, if I have 0 in the numerator, doesn't matter what my denominator is, this is equal to 0, and we are allowed to be equal to 0. This inequality is non-strict. So negative 1/2 is actually part of the solution. So if I put all of that together, our solution is everything from negative 5 to negative 1/2, including negative 1/2, but not including negative 5. And then everything above positive 4. So that was the probably biggest doozy out of this section that you're likely to encounter, and that is exactly how we would approach solving it. Get one side equal to 0, turn your non-zero side of the inequality into a single rational function, and then find the zeros of the numerator and denominator. Those are your critical numbers. Those are going to go on the number line, and then it pretty much looks the same as the polynomial approach from there. We just have to worry about those critical numbers that are maybe not allowed to be solutions. So always check your endpoints. You always want to plug those in, or try to plug those in, and see if they satisfy the inequality, or if they break everything, as negative 5 and positive 4 would do in this case. So that is all that I would like to present from 7.3. Go ahead and get started on those homework problems and bring any questions you have to class.